Let's go to the experiment number 3. To determine the volume of an irregular lamina, the screw using a screw gauge. So here this is your A, volume of an irregular lamina. This glass piece can be taken as a lamina. That's why I took it instead of a wire. I've taken it. So here this is an irregular lamina. And what is the apparatus? Your apparatus required is a irregular lamina and a screw gauge. So then, what is your working formula? Here, volume. You are finding out volume. Volume means area into thickness. Thickness you have already determined in the screw gauge in experiment number 2. Thickness using a screw gauge, so that's why I am taking a screw gauge. But you should add an additional, you must have a graph paper. There has to be a graph paper attached to it. Screw gauge, irregular lamina and a graph paper. So you will have a graph paper to be used with the apparatus. Because otherwise how do you find out the area? So that has to be changed here, children. This has to be additional a graph paper. So working formula, volume is area into thickness in cm cube, and then area, this is the area formula, and this is the thickness which you have already determined using a screw gauge. So table 1 will be thickness determined by screw gauge, table 2 will be determined area by a graph paper. So volume is area, and this is your least count of the graph paper. Least count of the graph paper is 0.01 cm square. N1 into 100, N2 into 25, N3 plus N4 into 0.01. Now what are these? N1 is the number of big squares. I am now explaining you the area determination. Number of big squares which are having 100 small squares. Acha, what is this 100 small squares? Each small square has a dimension of 0.1 square. So it will be area of 0.1 into 0.1, 0.01. 100 such squares are there. That means what is the dimension of this big square? 1 cm into 1 cm. So it is 1 cm square. Okay. Now, when I talk about a boundary in 4, I have made that diagram more than a 1 cm square. Just to tell you what are the precautions to be followed. Okay. So, don't mind my diagram. So, N1 is the number of big squares. N2 is the number of quarter squares. In a big square, how many quarter squares can be there? 4. 25, 25, 25, 25. So there are 100 squares. So N2 is the number of quarter squares left over. So 25 such small squares. And what is the area of each of these 25 small squares? Again 0.01. That is the least count of the graph paper. Smallest square. So N3 is, when you draw the figure, N3 is the number of the rest of the small squares within the line. N4 is the number of boundary squares having area half the area inside or more than half of the area of the small square inside the lamina. That can be taken as the complete square. So these are complete boundary squares which are taken as boundary squares. Only the boundary part of it, which you have taken as within some conditions, the rules. What is the rule? If it is more than half or half inside, it is taken as a complete one. If it is more than half outside, it is taken. Okay, so you can say that N4 is the boundary squares, N3 is the leftover, apart from big squares and quarter squares, the other small squares, each area 0.1. So here, now you know the lamina is a plane surface, thickness is determined using a screw gauge, refer to experiment number 2 for observation table 1, area is determined using a graph paper. So this graph paper was to mention in your apparatus required. Okay, so area of one big square, 1 cm square, area of one small square, I just told you, it is 0.5 to 0.1. Now boundary of the first procedure to determine area, draw the boundary of the lamina to be drawn on the graph paper. 3 such figures are drawn on the graph paper. Figures are numbered. Figure 1, figure 2, figure 3. Find out the area of figure 1 in terms of the formula N1 into 100, N2 into 25, N3 plus N4 into 0.01. Similarly for figure 2, figure 3. Number of, that means in figure 1, suppose I just focus on figure 1. Number of big squares to be counted and noted on the table 2. Number of quarter squares which are having 25 small squares to be noted. Then you have the number of the rest of the small squares to be noted, N3, and then you count the number of boundary squares which are N4, which are having more than half or just half. They are taken as included as complete small squares in the figure 1. I am only focusing on the figure 1 of this class. Okay. The above procedure is repeated for all such figures drawn on the graph paper, and then the area is calculated using the formula and the mean area is calculated. Okay. So product of the mean area and the thickness gives the volume of the irregular lamina. This is the procedure. And what is the table? You have a list count, number of big squares, number of small quarter squares, number of complete small squares, N3, number of boundary squares taken as complete squares N4, and then area N1 into 100 plus N2 into 25 plus N3 plus N4 into 0.01, where 0.01 is the least count which is written here. Then the mean area completely for the figures. Now here is the figure. I have drawn a figure. Sorry children, I have not taken this glasses. I have taken a figure, drawn a lamina. And here, I just showed you, this is a 1 cm square area. मतलब ये जो cross है, these cross parts, here I have put a cross mark. 1, 2, 3, 4, 5, 6, 7. So you have 6. 1, 2, 3, 4, 5, 6. So there are N1 is 6. The one big square has an area of 1 cm into 1 cm. When it has how many small squares? 100. So 100. So this is area is 1 cm square. So how many in this figure I have drawn? How many 1 cm square area is there? How many number? What is the number of the big squares? 6. Now the quarter squares. Now each big square, how many quarter squares it can have? 4. Now suppose the lamina goes from 3 lengths. So how many will be included? 3 only. So here you can see. See this? This part, here it has 1, 2. The dot parts are the quarter squares. 25. Each one has a 25 squares. Similarly, count this dotted part. You will see that 1, 2, 3. Then you have 4, 5, 6, 7, 8. You have N2 as 8. Can you see this? So this is N2 is 8. There are 8 25 wala squares. Now, rest of the figure, you have the small squares, count them. Your eyes will also play, but you have to count for determining area. So N1 is 6, N2 is 8, N3 is 120. Now what is N4? Which I have written here, it is 45. I have counted in this procedure. I have enlarged the smallest area. What is that smallest area? 0.01. I have enlarged, shown you the boundary that if this area, if more than half is taken, count it as 1. Take. This is cross. Then cross. This is because more than half is outside. Nothing is there. Only a bit less than half is here inside. So this way, the procedure here, see this, the figure goes, here it is, it cannot be included. This cannot be included. Here it is more than half is inside the lamina. So it will be included. So in this procedure, I have counted the N4 as 45. N4 is for this boundary. The smallest area, which are magnified 100 times. Or this area, one is uneven. So please, just to show you that which one is to be taken and which one not to be taken. Only for the N4 part. So N1, so for every figure, the total number should come as the area nearly the same. So N1 is 6, N2 is 8, N3 120, N4 is 45. Now N1 6, how many squares are there? 600. Because in each of these big squares, how many squares are there? Hundreds of small squares. So 6 into 100. So you will have 600 squares. Now N2 is a quarter square. How many squares are there in that? 25. So 8 into 25 will be 200. 8 into 25, 200. Now what is N3? 120. These are simple squares. Just you have counted them as small dots. And then this is, you have counted the boundary squares 45. The total comes as 965. Total is 965. And what is the area of each small square? 0.01. So 9.65 is the area of the first figure. Similarly, you can draw another figure and see, and you can see that there is number of big square 6. You have quarter square 7. That is 7 into 25, 175. 6, this is 600 plus 175 plus 141 and 52. Here you will get the 967. So this comes as 967, 9.67. Procedure is the same. So you have one lamina, but don't put it just like coinciding with one line. Just put it irregularly, so that you get the area more or less it comes the same. Okay. So then after doing the area, you are calculate the mean area on the table. This here the mean area. So 3 such areas will be determined, and then take the mean area. That's why I put only one observation. That's why I have put a blue dot. Only one value. So that you calculate the volume. Already thickness has been calculated by table 1 in the same procedure as in ES2 watch. In the experiment number 2, same procedure. pH, Piston, IEF, D, pH, PSR, CSR, PSR plus CSR gives you the thickness. So thickness for the table 1 observation table. Please write the heading in the observation table. Table 1, determination of thickness. Table 2, determination of area using a graph paper. Then put N1, N2, N3, N4 and area. Okay. Then volume calculated, result is volume of an irregular lamina is this much centimeter cube. So calculate the volume. Then comes the precautions. The precautions is pitch and its count to be determined carefully, number of observations to be large, parallax to be avoided, and then backlash error should be avoided by turning the skew head always in the same direction. Now, what is most important in the area? The boundary squares to be noted very carefully. Boundary squares to be noted very carefully. The squares having less than half the area, squares having less than half the area of small squares inside the lamina to be neglected. If only small area is there and most of it is outside, then this to be negative.